Telescopes image M87's supermassive black hole and massive jet together for the first time. Researchers studying M87's supermassive black hole in the heart of the galaxy have found where the monster's huge jet comes from. This is the first time that both the jet and its source have been seen at the same time. Also, the observations have shown that the ring around the black hole is much bigger than experts thought before. The results were written up in a study that came out today, April 26th, in Nature. The National Science Foundation's National Radio Astronomy Observatory, or NRAO, and Green Bank Observatory, or GBO, the Atacama Large Millimeter Sub-Millimeter Array, or ALMA, and the Green Bank Telescope, or GBT, were all part of the Global MMVLBI Array, or GMVA, which brought together radio telescopes from around the world to make these new discoveries. The most well-known black hole in the universe is the supermassive black hole at the heart of the galaxy M87. The Event Horizon Telescope, or EHT, took the first picture of a black hole, which was shown to the public in 2019. The picture of its thick, dark middle, surrounded by a fuzzy, bright ring, was all over the news around the world. M87 has been studied for a long time, and we knew the jet was there 100 years ago but didn't know what it meant, said Ru Sen Lu, an astronomer at the Shanghai Astronomical University, leader of a Max Planck research group at the Chinese Academy of Sciences and lead author of the new paper. Lu is also in charge of the Chinese Academy of Sciences Max Planck Research Group. With GMVA, which uses the best instruments at NRAO and GBO, we are observing at a lower frequency to see more details. And now we know that there are even more details to see. Eduardo Ross, who works as the scientific coordinator for Very Long Baseline Interferometry, or VLBI, at the Max Planck Institute for Radio Astronomy said, "We've seen the ring before, but now we see the jet. This gives us more information about the size of the ring, which is much bigger than we thought. Before, we could see the dragon and the fire, but now we can see the fire coming out of the dragon's mouth." By using a large number of different telescopes and devices, the team was able to get a better picture of the structure of the supermassive black hole and its jet than was possible before with EHT. Also, all the telescopes were needed to get a full picture. ALMA was able to separate M87's bright radio core, which gave scientists a clear picture of the object. VLBA, on the other hand, showed both the jet and the black hole in detail. The 100-meter collecting area of the GBT made it sensitive enough for astronomers to see both the big and small parts of the ring, which let them see the finer details. The first EHT images only showed a small part of the accretion disk that is thought to be around the heart of the black hole. If we change the bands we are looking at from 1.3 millimeters to 3.5 millimeters, we will be able to see more of the accretion disk and the jet at the same time. Scientist Tony Minter, who is the GMVA leader for the GBT, said, "This showed that the ring around the black hole is 50% bigger than we thought before." Not only have readings at shorter wavelengths shown that the black hole's parts are bigger than was thought before, but they have also shown where the jet's source is. The jet was powered by the energy made by the magnetic fields that circled the black hole's spinning core, and the winds that came up from the accretion disk that surrounded the black hole. These numbers showed, for the very first time, where the jet took off from. Before this, there were two different ideas about where they could have come from, Minter said. However, this observation showed that the energy from the winds and the magnetic fields are actually working together. Harshal Gupta, NSF Program Officer for the Green Bank Observatory, said this discovery is a powerful example of how telescopes with different but complementary abilities can be used to help us learn more about astronomical objects and events. The Green Bank Observatory made this finding. It is interesting to see how the different types of National Science Foundation-funded radio telescopes work together as important parts of the GMVA to give a big picture of M87's black hole and jet. How big are supermassive black holes? You can't see a black hole with your own eyes because, as their name suggests, they don't let out any light or other kinds of radiation. But they can be found because of the effect their gravity has on stars that can be seen in the area around them. Around the black hole, these stars move much faster than they would around a regular object of the same size. Astronomers can figure out how big a black hole is by looking at how fast stars circle it. NASA says that this is how they found out that the black hole at the heart of our galaxy is about 4 million times as heavy as the Sun. One thing that shows this is that there is a supermassive black hole at the heart of our galaxy. It sounds big, but compared to the biggest supermassive black holes ever found, some of which are bigger than 100 billion solar masses, this one is pretty small. Some of these black holes have been studied. Black holes are in the middle of galaxies. Most galaxies have black holes in the middle, but their small effects on the stars around them only hint at their presence. These black holes don't have the power to eat anything that gets too close. But in a busy galaxy, these supermassive black holes act very differently than in a passive galaxy. When there is a fast-spinning accretion disk of gas and dust moving around the black hole, matter keeps falling into the black hole. During this process, it gives off huge amounts of energy, which can sometimes make it so bright that it makes the rest of the galaxy look dim. In 2019, the Event Horizon Telescope was able to take a picture of one of these galaxies, which is called Messier 87, and get a clear picture of the impact disk. The black hole in the middle of the galaxy casts a shadow that looks like a black hole in the middle of the disk. This is because the mass of the black hole is equal to 6.5 billion suns. How supermassive black holes are formed. People often think of black holes as huge cosmic vacuum cleaners that eat everything they can get their hands on until there is nothing left. If that's how real black holes worked, it wouldn't be hard to figure out where the supermassive ones come from. After a normal black hole formed from the fall of a star, it would just keep getting bigger and bigger until it was huge. But real black holes don't eat matter this way. Instead, they just pull it in using the same law of gravitational force as any other object with the same mass. The fact that they are so close together and that the gravitational pull gets stronger with less space adds to what makes them so interesting. So, it is possible for an object in orbit to drift into a place where the pull of gravity is so strong. On the other hand, as you move away from a black hole, its gravity goes back to what it was before. But if a black hole can't pull in things from far away, you might wonder how it could ever grow to such a huge size. Even though there are a lot of interesting ideas, no one knows the answer to this question right now. It's likely that the important standard model of how black holes form had nothing to do with the first supermassive black holes being born. Instead, they could have formed almost quickly when a huge cloud of gas with as much matter as millions of stars collapsed under its own weight. A direct collapse black hole like this one would have formed in about 150 million years, which is a cosmic blink of an eye. Thanks a lot for watching.